All right, y'all. I think I gave my brain enough of a break that I'm not going to make any errors on this one. So let's do them. Okay, the graph of f(x) shown in the region above. A1 and A2 are positive numbers that represent the areas of the shape. In terms of A1 and A2, what are these? Okay. Areas are always positive, so it says they are positive numbers that represent the areas. But the integral depends. So this actual integral right here, so the integral from -4 to -1 of this function is A1 because it's positive because it's on the top, okay? Right here, this integral, the integral from -1 to 4 of this function is -A2, okay? Because like, let's picture, for example, guys, this had an area of, the integral is 4. Let's say this had an area of 8. The integral is -8 because it's on the bottom. It told me A1. Okay, so check this out. What's the integral from -4? Okay, what is the integral from -4 to 4 of the, and then 2, and then the integral from 1 to 4. All right, -4 to 4 means all the way across. Now this integral is going to be A1 plus -A2. So I'll just go ahead and call it A1. I'll go ahead and do that, plus -A2. Now, from -1 to 4, that integral is -A2, but I'm subtracting 2 times that. I just have like A1 minus A positive plus 2A2. This is A1 plus, oof, weird, but I like it. I'm going to pause after every question to make sure I'm not doing anything dumb. All right, that was good, y'all. We're on a roll. Let's see. The graph of the function is shown above of which of the following has the value. I can't remember talking about this. Reviews, okay? So we're basically talking about exact integral, the actual exact area, which is what the integral is. And then we basically have to talk about left, right, midpoint trap, okay? All right, so let's draw this left, right trap. And we're going 1 to 3, okay? I'm going to work up here. So I'm going 1 to 3. We're doing it in 4 subintervals, okay? Left area is going to be an overestimation. So that means it's going to be a little bigger than it should, right? Okay, so that's my left. My right is going to be an underestimation. So it's going to be a little smaller than the rest of them, right? Okay, and picture like the integral is this exact. The right will obviously be smaller than that. Okay, midpoint goes like this, like halfway between, it makes a rectangle. So midpoint, it's pretty accurate because it has like a little over, little like LE, a little over and a little under that end up like kind of canceling each other out. And then you've got the trap, which makes each of these a trapezoid, right? So it connects like, let's see. And I gotta erase these other parts because it's a little bit. Okay, the trap connects that. These all as like straight line trapezoids. Trapezoidal is like very accurate. And this is midpoint is pretty dang close. So those are the two most accurate ones, okay? If it says, what does it say? Which has the least value? It's definitely the right, because that's the one that is a much underestimation from, okay? Okay, cool. We love these U sub ones, you guys. What you do is you just say, like, especially it already gives you 2. That's perfect. Now you still have to do this step on the side. Sorry, not that yet. Okay, we go. U is square root of x. U is 1 over square root x dx. Okay, which means there needs to be a 2 down there and a 2 up. And then it becomes e to the u du. The first thing is it has to have a 2 in front of it, which means I can kind of get rid of those. Now, next, it's always going to have you look at this, you guys. We got to change our endpoints in terms of, okay? So, like, we take this 4 over here and we plug it in. Well, the square root of 4 is 2, so that'll change to a 2. I take this 1 over here and I plug it in. The square root of 1 is 1. It's 1 to 2. Okay? So, all right. If a is a linear function and a, b are both positive and a is like smaller, interesting, then what's the integral of the second derivative? Okay, check this out. All right, f of x is a linear function. We go with that? Okay, is that cool? F is mx plus b because it's linear. F prime of x, well, the derivative of that, that's a constant, and a number times x is just a number. F double prime of x is 0. So this is asking me, what's the integral of 0, right, from a. Well, you guys, the integral of 0 is 0 plus a constant, though, right? Evaluated a to b. But we're taking this with respect to x. And so I would plug in a for x. There is no x. So that just equals the constant right here. And then I would plug in b for x, and there is no x. That's crazy. The integral is 0. The integral from a to b of the second derivative. Weird. I don't like it, but I mean, that's what it is. You know, if you think about it, if an integral goes to this, it goes to the first derivative. But then, and that's just a number, and we're evaluating it. Well, it's just going to be the number minus the number, you know? So, kind of weird, but we're going to get 0 on that. All right, cool, guys. We got our second fundamental theorem of calculus, which says that if we take the derivative of this, right, a derivative and an integral cancel each other out, and just, so f prime of x is square root of x to the first one. Guys, the only time you would ever have to do a chain rule or something like that is if not x, right? Then I'd have to multiply by the derivative. But we're not doing that. We're just plugging in an x. There you go. So now, what's f prime of? Well, it's the square root of 2 to the third. 2 to the third is 8. The square root of 9. Okay. Now, this is tricky, like real tricky, you guys. I don't know. There's no such thing as a product rule for integrals. So I'm actually not entirely sure that there's a shortcut way to do this. If this were me, okay, number one, I wouldn't do it right now. I know it's going to take me some time. Watching for time on your AP, okay? I would like to come back, but I would look at each of these. Okay, let's see what I could automatically like. Like, dude, I feel like it's definitely not going to be that because that just took the x out and then did x squared over 2, and like we know it doesn't work. Okay. It's not going to be that because that's super weird. That's like a product rule. I just think that's super strange. The rest of them, like, I'm not. Okay. So let's start with A. I'm going to go ahead and take the derivative of this because the derivative of the answer should then x f of x. Okay. I'm going to work backwards because that's kind of all I wrote. So here we go. This would be a product rule. It would be derivative of the times plus first times derivative. And then the derivative of an integral is just x f prime of x. So that and that cross out. And so I get f of x. That is not what I want. X f of x. All right. Now I'm going to take the derivative of this next one. So I'm going to go, okay, the derivative of the first, so that's going to be 2x over 2, so that'll be x f of x, the first times second, and then first times derivative of, and then the derivative of an integral cancels out. That looks pretty great, actually. I'm thinking those two cancel out, and it gives me x f of x, so I'm actually thinking it's that. We could test the last one, though, just to kind of make sure. Okay, if I do the derivative of the first times the second, first derivative of the second, and the derivative of an integral is that. Nope, nothing cancels out there, so that's okay. So I'm gonna say this is E. All right, interesting, very funny. Hey, here we go. Function is continuous on a closed interval. Value shown in the table. Do intervals, approximation, left. Pretty straightforward question. The base on the left, the height is base of that interval. On the left, the base of that interval is 1, and the base of that interval is 5 times the width 6, -4, -21, 7. Okay, pretty straightforward, no other information given there. Now we're going to look at some FRQ. Okay. Gotta read these better because I'm confused. Okay. Out of my. All right. 8 goes with this graph. Okay. Here we. Okay. So I have the graph of a differentiable function. This is f. I'm using the graph. Write down what it is. A regular. Let h be the integral from 1 to x of f of t between 1 and 0. Find a value of which has the. Guys, this is something I want to go over that I feel like we haven't gone over enough. Okay. So the fact is h has its minimum. If it's on a closed interval, we're actually talking about absolute minimum. And what I want you guys to remember about absolute minimum is, okay, I want you to remember that you have to check endpoints. And in this case, like, here's my endpoints right here, yeah? 1 and 7. And then I need to check critical points. Hey guys, you really got to think about this. You can't just go, oh, look, critical points are where that equals 0. No, think about what it's asking you, yeah? Okay. H, we're looking for where H has a minimum. So I want to know where H has critical points. H has critical points where H prime of x 0. Let's take the derivative of that's taking this. Boom, boom. H prime of x is the same thing as f of x, which equals, so what's those? 5, and then 7 is just the endpoint. Okay? Now, I'm going to do a sine line graph, you guys, and my sine line graph is going to go from 1 to 7, and I'm going to have 5. Okay? And remember, I'm testing this into time, but h prime is f. So what's f of 6, for example? That's a negative number. And so the graph of h is increasing, decreasing. Find the value of x at which h has its minimum. Okay, now, this is rough because if it asks me where's the maximum, boom, at 5, I'm golden. If it asks me where the minimum is, which I need to narrow it down, and I know is at 1 or 7. Okay, because that's the endpoints, and because it goes up and then down, right? The min is either at 1 or 7. And let's see if we can figure this out. Now, if it gave me any information about like, f of 1, well, or h of 1, whatever, but didn't give me any more information. So just think about this, okay? At 1, oops, sorry about that. Oh, no, actually we could do this. Okay, I need to evaluate h. Okay, let's think about this. H of x is the integral from 1 to x of the function. Well, if I'm finding h of 1, it's the integral from, hey guys, which is 0. So h of 1. Now, let's figure out what h of 7. So h of 7 is the integral from 1 to 7. Now look, you guys see how I've got all this big area up here, which is, I don't know, positive because it's above the axis, and then this little baby area right here, so you take off a little bit of a negative. But the positive area is bigger than the negative area, which means h of 7 is positive. Okay, so we could say h of 7 is something positive because of that area there. So what is the absolute minimum? So h has a minimum at x. All right, the justify is kind of like all the work that I just showed there. We could take a look at if there was a special justify on this one. Okay, you get a point for the correct answer, so chillin'. All right, we get a point for eliminating the interior point. We did that because that was a max, and a point for eliminating 7. There's a minimum because it increases indentation. Minimum endpoint. And then it basically shows what I showed, which is R1 minus R2 is positive and H of 1 is 0. So they didn't have any special way of trying to see if they had a special way of writing it. Not really. They showed that, which I showed. Hard. Love it. All right. Let's look at number 9. Now for number 9, that's going to go with this. And, okay, that's just FRQ. All right, so this is number 9. Find the average value on the closed. Guys, I'm going to, value means average value of f of x 1 over a, the integral from a to f of x. So on the interval 0 to 5 means it's 1 over 5 minus 0. Integral from 0 to, now here's the problem. This is a piecewise function. So I have to stop, okay? Now I'm still going to let it be 1 over 5 out. But I have to split these integrals up. It's going to go 0. 1 is going to go 5. Now from 0 to 3, I need to integrate this one. And then from 3 to 5, I need to integrate that one. All right, so this is like a lot of steps, but that's okay because this is an FRQ, so we expect that. All right, Jesus. Okay, I'm gonna use some different colors. All right, the integral of x du is dx. So I can basically change this. And half. Recorded. I didn't change my endpoint. 3 actually now becomes 4, and 0 now becomes 2/3. I gotta do 4 to the 3 halves, 1 to 4 to the 3, 4 to 4 is 1 to the 3 halves, which is for that first part, okay? And now I'm going to do the second part. This is not a U sub. This is just straight integral. The integral. And so if I do top minus bottom, okay, when I plug in 5, I get 25 minus 25 over 2. When I plug in the bottom, I get minus 9 over 2. Okay, I'm actually not going to get a common denominator just yet. What I'm going to do is distribute that to minus plus 9 over, okay? And then I'm going to combine it 10, and then I'm going to combine now. Okay, negative 25 plus 9 is negative 16, and negative that equals. Okay, so the average value is 1 over, and then the integral, third plus. Now that should suffice just fine for you. Okay, you're completely fine at that point. If you want to 32 thirds, 1 over 5, or 30. All right, so there's my average value. For heck's sake, guys. Tiniest a correction here. 25 minus 15 is 10, but 25 minus 9, I'm literally going to have to do this. 10, 11, 12, 13. Is 16, which is 10 minus 8, which is 2, for goodness sakes. All right. Yeah. So then that's actually just 2, and we could leave our answer like that, for sure. Or, again, we could go like this. Okay. 6 over 3, that's 20 over, which would give me 20 over 15. Or, no, hold on. 4/6. Hey, this is why a good night's sleep before your AP test is important. I'm not saying I didn't get a good night's sleep. I'm fine, but brain has hard time functioning when you're tired. And also, like, I'm doing this at the end of the day, right? So, a lot going on. It's better, which is why your test. That's good. All right. The rate of consumption of Diet Coke in Mrs. Mitchell's classroom is given by S of t equals t to the k, e to the kt. S is measured in billions of gallons. Accurate, may I say, accurate. And T is measured in years from 9. Okay, look, I was 3 in 1980, but we're gonna go with this. Oh, the information really gives me. Oh, for goodness sakes. All right. Use the trapezoidal rule with 4 equal subdivisions. Estimate 7, 5. Does it give me? No. Supposed to be. Bizarre. Okay. So at t equals 5 is 95. 7 is 97. My trapezoidal rule is 4 subdivisions. That would be 5.5. That would be 10. You guys remember for trapezoids, it goes, okay, it's 1/2 the base sum of the height. The base is 1/2, and that's going to be for everything. It's going to be 1/2 base, because those bases are all the same. They're all spread out. And then it's the sum of the height. So it's going to be, now let me do this first. the first set of heights is going to be f of 5 plus f of 5. The next set of heights will be f of 5.5 plus f of 6. Next set of heights is going to be f of 6 plus f of 5. The next set of heights is going to be f of 6.5 plus f of 7. You guys see there's one of f of 5, and then there's two of those, and then there's two of those. Okay? So look, I have to find what f of all this stuff is. Well, I'm plugging in those numbers for. So if this for s of t, it's the k, whatever. All right? It's going to be trippy, but if I don't have equations, this I'm going to write it. So it's going to give me, okay, 1/4. And then it's going to be, okay, so f of 5 would be, right? Then I have two of these. 2 CE to the 5.5k. Then I have two of these. 2 CE to the 6k. And then I have two of these. 2 CE to 6.5k. Then I have one of those. That's my trapezoidal rule. And it's like worth of all of that. And my C's look like parentheses, whatever. Let's see if that is what this is. Or on this. That was the last question. 1/4, boom, 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 boom. Okay, cool. Well, they actually just left it like that and put S of whatever, but my answer is still correct, but like weird. Okay, but that's fine. All right. Got number. Gives or number helpful, and then we got that. Rather than use, oh no, sorry, let the function be given by that. Rather than using the line x equals okay, hang tight. All right, math. I'd like you guys to know it's like it's moving to the right 3. That's what this looks like. Okay? It sounds like this had a two-part question. First part, it said you find the. I'm actually going to do this because it'll help me figure out the next part. Anyways, area would be integral of that, rather than using line of part A. Okay. Then I could integrate that and I could find the area. Now consider the line x. Tell me. So it's almost like I'm taking this line and okay. Let's say I put it over here and I'm finding that x, right? Well, it's just the integral from okay of x minus 3. So let A of W be the region enclosed by that. That looks like that's it. I don't know if there's anything else I can do on that one. Take a look. What we got. These are weird questions. 3. Okay, yeah. Fine. I'm just like not feeling confident. All right. Last thing. This is actually really good. Water is pumped into a tank. It's going in at a rate of 8 gallons per minute. Water is leaking at a rate of plus gallons for time 0 to 120 minutes in the first 2 hours. At time 0, it contains 30. That's important, guys. That's where we always like, that's where a lot of times we forget to start with that 30 as first thing, right? So here we go. At what time is the amount of water in the tank? Okay, so let's figure out how much water is in this. Also, very good question. Okay, the water in my is represented by 30 gallons of water plus integral from 0 to 20 of 8, because it's coming in at a rate of 8 gallons per minute, plus, nope, minus the integral from 0 to 120 gallons per minute. Okay? All right, now, I can like figure that out. Well, actually, okay, at what time is the amount of water in the tank at maximum? That's actually if all of my time, but for right now, let's just say to, and then I'm not really supposed to, so I guess I'll use like X's or something. All right, it's not a huge deal. Let's go. All right, you guys, so there's my equation. Okay, uh, in order to find maximums or minimums, right, we have to do, okay, we have to check endpoints and critical. Okay, endpoints are easy. Starts at time 0, it ends at time 120. Those are my endpoints. Right, critical points is where the derivative of water equals 0. Okay, you guys, check this out. Derivative of 30, the derivative, I want to set that equal to 0 and see what time that will, I'm going to move a root of right, the time at, okay, and that's my critical. So here we have it, guys. I'm going to make a chart. This is, okay. I mean, I can put X, Y, but just so you understand. Time and water in the tank. Okay? I need to figure out how much is it 0, how much is it 60, and how much. Now 0 is pretty easy, guys. It told us that. 0, starting with 30. I'm integrating 8, and then I'm subtracting the square root of x plus. Okay, so that I don't have to. Right? It told me it had like. Also, technically, okay, let's go ahead and do U sub. Let's see. U is x, U is x. Really change it. All right, okay, here we go. Top minus bottom. I should need to get 8 times 6. this one. Let me so it's okay. The 2 on the bottom is square root of 64. That's 8. 8 to the third. I think that's 5. Oh, no talk. Okay. The square root of 1 is 1. 511. It does not divide by 3. Before I go on too much farther, check if I'm right so far. Hold tight. All right, guys. I actually am right in my work, but I just realized I don't actually think hold on a second. At what time is the water in the tank a maximum? I don't know that I need to do all that. Okay, you still could, but I don't know that I need. Because look, if I'm going from 0 to 120 and I have a critical three, actually, what I'm going to do is I'm going to show that this is the derivative. Okay, you guys check it out. That's the derivative, remember? Okay, so let's pick a number between 0 and 63. Let's pick something that when I add 1, it gets 6 15 plus 1 is 16. 8 minus square root of 16 is 8 minus 4 is 7. Now let's pick something. Let's 80 plus 1 is 9, and 8 minus 9 is a negative. So, because, and only because it's asking me for the max, I can say right here that at time equals the water is at a max level. Why? Because f prime of x, of prime, but is changing from positive at not many of them are putting it. Ooh, that's bad. Don't put it, my friend. Put w prime of x. Okay? I mean, I was like on the right track here. Shoot, I kind of just want to I just want to finish it. Just quick. I mean, I'll use a calculator, but minus 2/3 times what? This time is it point. And then the maximum amount, I'm just going to do this real quick, guys. It's going to be 30 plus 120 times plus 2/3 of 120. 2/3 of 120 minus. Anyways, that's going to be the highest. Hold on. I'm going to pause and figure. Okay, there you go. Boom. 103 point. If I had more time and interest, I suppose. Like, this is actually an acceptable way to show it. But when those calculations started getting away from me a little bit, I was like, I'm thinking there's an easier way. Try the sine line graph first, and I got to check, right? Um, so the minimum that was 30, if it went below 30 or if it started later. Okay, anyways, that wraps up. It's 6, guys. All right.